Welcome to the data analysis section of this BeyondFormulas Excel modeling training series. Aggregating data used to be a lot harder. My grandfather used to tell me about an entire room of analysts at their engineering firm who would manually update giant wall-based spreadsheets completely by hand using slide rules, since in those days they didn't even have calculators. Things have undoubtedly gotten a lot easier, and so the goals of this lesson are to teach you to use a range of aggregate, conditional summary, and comparison formula that will allow you to analyze datasets, to learn how to create a list of unique values from a large dataset, and to describe your data to infer meaning and identify patterns that bring understanding and insight. The tools we'll learn about include aggregation formula, conditional aggregation formula, and comparison formula. For this lesson, you'll need the COUNTBLANK Case 5.1 Basic Aggregation Starter File. By the end of this video, you would have learned how to use a suite of aggregation and summary formulas and apply them to the sales data in this case example. When presented with any data, as an analyst, your first job should be to always pore over it and dig through to find useful patterns and stories that help you understand what the data actually means. These descriptive tools are the means by which you can do that. Let's dive into Excel now and demonstrate. Within the 5.1 Basic Aggregation Starter file, I've created a blank set of activities for us to perform together. Let's start with a basic summary formula. And to bring this back to the COUNTBLANK case example that we began earlier, we're going to apply all of these aggregation formula to the COUNTBLANK sales data. If you have a look at the 2013 sales data tab, you'll notice the flat file of sales data, which has already been converted into a table and given the name Table Sales Data. To access any of these fields, we should just be able to start typing Table Sales Data and look for the appropriate field. Let's go practice now. Heading back to the Sales Data Analysis tab, our first task will be to add up all of the revenue for COUNTBLANK. To do this, we're going to type equals, hit sum, and start typing our table name. This brings up the Table Sales Data option, which we can move down to using the arrow keys. Once the correct one is selected, hitting tab will autocomplete, and our next goal will be to find the appropriate field. Hit open square brackets to open the autocomplete list, which exposes all of the fields in the table sales data. In this case, we're interested in revenue, which you can access by beginning to type revenue, RE, and then hitting tab once the appropriate one is selected. Close the square brackets, and close the regular brackets to complete the formula, and hit enter. I'd now like you to repeat the same steps for the rest of the basic summary formula above. Notice how simple it was using the tables method to create any descriptive statistic you liked, from the number of cells to the number of non-blank cells, which are thankfully the same, to the median, to the max, and even the standard deviation. Next, we're going to look at a brand new formula that Microsoft introduced in Excel 2010, known as the Aggregate formula. The Aggregate formula lets you achieve exactly what we just did in the basic summary formula section, but with a single formula. To use it, we type equals and type Aggregate. To autocomplete the formula name, hit tab, which now brings up the first parameter of the aggregation type. You'll see that you can select from all of the available aggregation methods. To calculate the sum, we'll select number 9. Hitting comma opens up a range of additional aggregate options, and basically exposes the only real reason you would choose the aggregate formula over any of the specific sum, average, or median formulas. The aggregate formula is good at ignoring certain types of data that may otherwise break your aggregations. You may easily ignore everything from hidden rows, to error values, to other aggregate results or subtotals. Used correctly, this can help you avoid the issue of double counting those values. In my experience so far, the usefulness of this feature has proven limited, largely because I believe that the design and structure of a model is what helps you to avoid errors like double counting. One of the downsides of the aggregate formula is that it becomes very hard to read, since you cannot easily see that 9 is sum, 1 is average, and 12 is median. For the purposes of this tutorial, let's complete the exercise. However, we'll cheat a little and allow the first parameter of the aggregate formula to take the value of row 12, which I've already pre-populated with the code corresponding to the relevant aggregation type. For the second option, we'll select 4, which is ignore nothing. This makes it equivalent to the formulas you used above. And for the last parameter, we'll add back our table revenue range. Closing the square brackets and closing the brackets allows you to complete the formula, which you can then drag across to the end of the range. Having completed basic aggregation, we're now going to move on to conditional aggregation. This allows us a measure of filtering in how we do the aggregation. Let's say, for example, that we'd like to add up all of the revenue by each month. With conditional aggregation, this is easy to do. We're going to start by hitting equals and typing SUMIF, which allows us to aggregate data using one criteria. We'll cover the SUMIFs function in the next section, allowing us multiple criteria. Hitting tab auto-completes. We'd like to look through the table's month field, find all records that have a 1, and then add the associated revenue. Let's complete that now. Let's start by typing the table name, auto-completing with tab, opening the square brackets, and going down to select the month field. Hitting tab and closing the brackets brings us to the second parameter, which is the criteria. We'd like to add up all values that have a month value of 1 on the left-hand side. And the last parameter required to complete the formula is the sum range, which is our trusty revenue field. Start typing table, select the sales data, and select revenue. Close the brackets and hit enter to calculate the result. Now all we need to do is drag the formula down to row 12. And voila, we have our 2013 sales broken down by month. Notice that the total corresponds to the total we calculated previously. This tells us that all values have been correctly included in our new SUMIF formula. We can now repeat this process for average and count, which both have a conditional version of their own. Notice that I now have an average monthly revenue by month and an average of those averages, which equals 2,888. But when we first completed the average formula, based on the entire dataset, we received a value of 2,895. This raises a common analyst pitfall with averages. Averages are fine when they're applied to your base data, but be careful of applying averages to averages, since this implies a kind of weighting that you probably don't want included in your data. Next, complete the same steps for the COUNTIF field, but note that this time there is no sum range, since the objective of this function is only to count the number of rows in which the condition is met. We can see that the number of orders per month tend to be relatively consistent, and that our total number of sales entries, 12,410, corresponds to the same number that we calculated previously. But we can now take this one step further. Excel 2010 and later allowed us even more power by providing us multiple criteria. You can access this using the SUMIFs formula. Typing equals and typing sum lets us select the SUMIFs formula, which has a slightly different syntax from the single criteria formula. This time, we're going to start off with the range we'd like to sum. Remember, this was the table sales revenue field. After that, we can then specify one or multiple criteria as we like. The first criteria we'd like to perform is the same one we did previously, where the month field equals 1. And so we typed sales data, month, and add cell D46 as the third parameter. Hitting comma allows us to add a second set of criteria. We want the CBSA field within the table sales data to equal the CBSA value in cell E43. To enter the CBSA field, we start typing the table name, hit open square brackets, and use the arrow key to scroll down to CBSA. Hitting tab and closing the brackets allows us to move on to the final criteria. In this case, we can click on cell E43. Since we'll want to drag this formula down, it's advisable to hit F4 to switch our references to absolute, which adds the $2 signs on either side. This means that when we drag the formula down, cell E43 will stay in place and will not move down relatively. So let's close the brackets and hit enter. Copying this formula down, we can calculate that 16.5 million of our total revenue actually comes from Los Angeles and Long Beach, and we can break that further into monthly revenue for that specific CBSA. If you were to go and tie cell E43 to a unique list of all the available CBSAs, this would become a dynamic summary tool that could allow you to quickly and easily present the monthly sales data for any CBSA. Go ahead and complete these steps for the AVERAGEIFs and COUNTIFs functions now. Lastly, we're going to cover a couple of comparison aggregation techniques. These allow us to use aggregation methods to compare various aspects of our data. You will frequently need to come up with a set of the unique values inherent in a dataset. Excel makes this pretty easy. To start, let's open the 2013 Sales Data tab, move your cursor into the CBSA field, hit Ctrl, Shift, and down to select all of the rows with CBSA names. Copy those by hitting Ctrl C, and then go back to our Sales Data Analysis tab. Move your cursor to cell D64 and hit Ctrl V to paste those values. You now have a list comprising 12,400 rows of the sales data CBSA names. But we're only interested in the unique values in this list. To chop this down, we're going to go to Data and use the Remove Duplicates function. Excel will ask you if you want to expand to include a broader selection or use what's selected currently. We'd like to proceed with the current selection and remove the duplicates. Since we've only pasted the values, our data does not have a header, so you should untick My Data Has Headers and then click OK. Excel has now conveniently reduced the 12,376 duplicate values to a mere 34. To begin this comparison section, we're going to use the SUMIF formula we learned earlier to add up the orders and the revenue respectively. Let's complete that now. Hit equals, type SUMIF, hit square brackets, and find the CBSA field. The second parameter in the SUMIF formula should be the CBSA name in the unique list we've just created. And finally, we want to sum up the number of orders. Select the sales table and find the orders field. Complete the formula by closing the brackets and hit enter to see if it worked. Ideally, we'd like to be able to copy this formula using Ctrl C and paste it in the Revenue tab. However, when we do so, notice that the Criteria cell, which previously pointed at Los Angeles, has now shifted over one. This is because we forgot to change our absolute and relative references. To do so, go back into your cell E64, click into the formula row where the appropriate cell reference is, so that your cursor is blinking on one of the characters of the cell reference, and hit F4 to toggle through the absolute and relative cell reference options. In fact, we'd like the row number to change as the formula moves down. To do this, remove the $ in front of the 64 by continuing to toggle F4 2 more times. Hitting enter and copying this formula again now shows that we have this correct. We had intended to add up the revenue rather than the orders in this field, so click into the formula once again and change orders to revenue. Lastly, select both of these formulas and copy them down to the bottom. Now that we have our summary statistics by CBSA, we'd like to get into some comparisons. Let's start by ranking our CBSAs in terms of revenue. To do this, select the rank function. The first parameter is the value associated with this CBSA entry, so move the cursor over to F64. And the second parameter to the rank function is the set of all the available values out of which we'd like to rank this one. Again, move the cursor over to F64 and hit Ctrl, Shift, and down to select the entire range of values. Close the formula with the close brackets and hit enter. We'd like to be able to drag this formula down, but looking at the formula, we forgot to use absolute references on the comparison range. Click back into the formula and use F4 to toggle both cell ranges to be absolute. Hit enter to complete the task. We can copy this formula down to the bottom by moving our mouse into the bottom right corner of the cell until the cursor becomes a black cross and double clicking. This triggers the fill down command. With just a few keystrokes, you have now determined the rank of each of the CBSAs as far as their total contribution to annual revenue. Next, we're going to calculate the percentile in which each of the CBSAs sits. Hit equals and start to type %. Scroll down to the %rank function and hit tab to autocomplete. This time we want to do it the other way around. We'll start by selecting the entire range to begin with, so move your cursor to F64 and hit Ctrl, Shift, and down. While doing so, don't forget to add your absolute references by hitting F4. Then hit comma to move on to the final parameter. We want to see where in the overall distribution of revenue this CBSA's revenue falls. Close the brackets and hit enter. Although the value is 1, we know that there's something wrong, since this formula is intended to return a percent. Go to the Home ribbon and click on the percentage formatting style to quickly correct this. Double-click on the bottom right-hand corner of the cell to fill down. Notice that it just so happens that these CBSAs are, generally speaking, in rank and percentile order. We can easily resort this by selecting cell D63 and hitting Ctrl-Shift-Right and down to select the entire dataset. To run a customized sort, we go to the Data ribbon and hit Sort. This now allows us to do whatever custom sorting we like. I'd like to sort by CBSA name from A to Z. Hitting OK completes the sort. But let's assume we want to instead look at the level of revenue for each decile. The percentile function helps us do this. Starting with the table of deciles on the left-hand side, hit equals, and then type percentile. The range we're looking to input is the range of all revenues by CBSA, so click into F64 and hit Ctrl-Shift-Down. The last parameter we need in the percentile function is K, which is the percentile of that distribution we'd like to return. In this case, select cell J64 so we can return the 0th percentile. Close the formula and hit Enter to return the value. And once again, fill down. This table now tells us that the 90th percentile city earned around $2.3 million in 2013, while the largest city returned $5.6 million. To round off the comparative statistics section, I'm going to teach you how to find the nth smallest and nth largest of any dataset you're looking at. Hit equals and type small, and tab to autocomplete. The small and the large formulas use the same syntax, which requires the full array of revenue followed by the number n smallest or largest item you'd like the formula to return. Let's go across and input the total array of revenue in the first parameter. Go to cell F64, hit Ctrl-Shift and down, and don't forget your absolute references, hit F4. And finally, we'd like the first, then second, then third, then fourth smallest item. Close the formula with the close brackets and hit Enter. Once again, fill this formula down by double-clicking on the bottom right of the cell. While this formula has told you the 10 lowest revenue levels by CBSA, it doesn't tell you which CBSA is responsible for them. For this, we can just use our index and match lookup. To do this, type equals and then index. We'd like to return the CBSA value that corresponds to the row in which this revenue value, 16,000, is found in our overall dataset. To do this, the first parameter of the index function should be the CBSA names. Move the cursor to D64 and select the entire dataset. Notice that I've already previously named this range Ag Test CBSA names. For the second parameter, we're going to use the match function as taught previously, where we'd like to look up the lowest revenue number in cell N64 amongst all of the available CBSA revenues found in the range from F64 and below. Once again, don't forget your absolute references. Since the small function returned an actual value from this revenue range, we can use exact match rather than an approximate match. And since this is only a single column lookup, we can complete the formula and hit Enter. Notice that the formula has returned that Crescent City is in fact our smallest CBSA, and filling this formula down by double-clicking on the bottom right-hand side completes the calculations for the rest of the 10 lowest revenues. We can easily apply this exact same approach to finding the largest CBSAs using the large function. Since large works exactly the same as small does, go ahead and complete the final section of this table now. Compare your results with mine. To review what we just covered, we started by learning a set of basic summary formula. We then looked at conditional aggregation using both one and then multiple criteria. And finally, we looked at a set of comparison statistics, including ranking, percentiles, and how to calculate and look up the smallest and largest n values in our dataset. These tools should provide you everything you need to get started as an analyst. But remember to always check your work, check your logic, and check your absolute and relative cell references. Thank you and good luck with the next section.